Hi guys, Assalamu alaikum. Today we are going to start our lesson on organic chemistry. So in this lecture, you people will be able to learn about the structures and writing formulas of alkanes, alkenes, alcohols and carboxylic acids. So let's begin this lesson. Bismillahirrahmanirrahim. In order to meet the objectives of the lesson, we must know what basically bonding of carbon in organic compounds is. Carbon is having 6 proton number, means it has 6 electrons. 4 electrons are the valence electrons. So here in dotted form I have shown the valence electrons of carbon atoms. In order to complete its octet, it needs 4 electrons. So in order to utilize it in all bonding, it will share with hydrogen. Most of the times it will, in organic chemistry, carbon and hydrogen is basically basic compounds, hydrocarbons. So it will share its electron with hydrogen atom to form one single bond. So 1, 2, 3, 4. So it is going to form 4 single bonds or utilize 4 bonds in either double bond or triple bonds, but total bonds which carbon atom will utilize will be 4. 1, 2, 3, 4. So why carbon forms many compounds? Because it forms long chain of carbon compounds. It can form branch chain of carbon atoms, ring of carbon atoms, multiple bonds between carbon atoms of other elements. Basically, carbon is having the capacity to form a number of compounds through which it is going to have long chains, branch chains and ring of carbons. We are going to learn about the detail of different homologous series, how carbon is involved in the bonding and how carbon is involved in different kinds of structures. So we are going to discuss first the alkanes. First homologous series, the carbon containing compounds are basically considered and comes under the organic chemistry. So alkanes are the saturated hydrocarbons. What does hydrocarbon means? Hydrocarbon means the compounds which contain only carbon and hydrogen, and saturated means it is going to form carbon-carbon single bond. So here we are going to learn about two things. Saturated means carbon-carbon single bond, and hydrocarbon means it contains carbon and hydrogen only. So these two elements when only present in a compound, then we will say it is hydrocarbon. And if there is saturated means carbon-carbon single bond. No double bond is present between the carbon atoms. So general formula for alkane is CnH2n plus 2, where N is basically the number of carbon atoms. N is number of carbon atoms. I will give you the link below where already I have discussed about the naming of the homologous series and functional groups. So here in this lesson we are just going to discuss about the formulas and structures. So this is the general formula. If we want to know the number of one carbon atom, it will be methane. We will put the formula here and get the answer. For example, if we want to get to know about the butane, how can we get butane after putting the values in this N? So N is, if we have 4 number of carbon atoms, the formula will be 2 into 4 plus 2. The formula will be, after solving it, C4H10. So this is the way through which we can get and calculate and use the general formula to get the molecular formula of the respective alkane. If it is butane, propane with 3 carbon atoms, ethane with 2 carbon atoms. So it depends upon the number of carbon atoms which basically they contain. So the next, the stem name of alkane. Sorry. The stem name of alkane will end up in ane. So methane, ethane, propane, butane, pentane, all series will come along with this ane. So molecular formula for the first carbon atom is methane, and if there are 4 carbon atoms, it is butane. So how to write the structure formula of this methane and butane. If we are going to consider the structure formula of methane, then methane is going to utilize one carbon atom. The rest of all will be the hydrogen because it is a saturated hydrocarbons and all will form single covalent bond. When we will come towards the butane, number of carbon atoms are 4, 1, 2, 3, 4. So all rest, each and every carbon atom will utilize 4 bond. 1, 2, 3, 4. You can check it from here. 1, 2, 3, 4. So it should be 4. But rest of, if other than 4 carbon atoms, rest of all the bonds will be utilized by the hydrogen atoms. So this is the way through which we are going to write the full displayed formula, structural formula or structure formula, where all the bonds are shown, how many bonds are formed, all the structure is going to show what basically the structure formula is. In condensed formula, we will form it like if it is C, then we will condense all the number of atoms like CH4. In this chain, all carbon atoms attached with the hydrogen atoms, we will condense it like CH3, CH2, then again CH2 and then CH3. This is the condensed formula through which we can write the condensed formula. Another formula which is the dot and cross formula. Dot and cross formula is shown like this. One line, remember, one single line donates like this. One single line in butane shows one pair of electron. One is from this carbon, one is from this carbon atom. So one basically single bond is shown, 2 electrons, one from one atom, another from another atom. So all single bond shows dot and cross, dot and cross, dot and cross, dot and cross. So this is the way through which we will write dot and cross formula of alkanes. So this is the way through which we will write the formula of alkanes. Saturated hydrocarbons, carbon-carbon single bonds are present. We can calculate we can get the molecular formula by putting the value in N. We have the general formula is CnH2n plus 2. So another one is alkene. Alkene basically is the unsaturated hydrocarbons. What does this mean, unsaturated carbon atom? Unsaturated means that this compound contains carbon-carbon double bond. So presence of this carbon-carbon double bond is going to give this characteristic of alkene. Whenever you will get this C double bond and C in a chain, then remember that this is a compound of alkene because this is the functional group of alkene. And functional group is that group which gives its characteristic properties to this compound. So alkene is with the carbon-carbon double bond will be there. And what does this hydrocarbon means? Yes, the compounds which contain carbon and hydrogen only. So in this compound again we will have not any other element in the chains, carbon and hydrogen only along with the carbon-carbon double bond. What basically functional group is? CnH2n. N is the number of carbon atoms. If we want to know the molecular formula of ethene, so if we are going to have the molecular formula of ethene here, then important thing, eth, 2 number of carbon atom, ene is the ending name of alkene. So this is the ending name of alkene. Eth mean number of carbon atoms 2. If you want to have see my lecture on naming of the hydrocarbons and all the homologous series, you can watch that video. The link will be given below this video. Okay, this is the ethene in which C2H4 molecular formula is there. If we want to open this formula, how we will open it in structural formula? Carbon-carbon double bond, it is must because it is unsaturated hydrocarbons. 1, 2, rest of the 2 bonds will be utilized by the hydrogen atoms. One is this hydrogen atom, another one is this hydrogen atom. So carbon-carbon double bond, 1 hydrogen atom here. Each and every carbon atom will utilize 4. 1, 2, 3, 4. Compulsory part in alkene is this functional group, that is carbon-carbon double bond. And again, this carbon atom will utilize 4, 1, 2, 3, 4 single bonds. So it is going to look like this. If we want to condense it in condensed formula, how we will condense it? Yes, C will be bonded with these double bonds. Along with it, we have two hydrogen atoms will be written CH2. The bond is between C double bond. We will not write it like this, CH2, CH2. It will be the wrong one. The exact way to write it is H2C, because carbon-carbon double bond will be present there. So this is the formula of ethene. So single bond is shown. Here is double bond. So we will show it double bond. Double bond. Double line shows double pair of electrons. So in dot and cross formula, we will show double bond, 4 electrons, 4 pairs are there with this, and 1 pair is here in this. So this is the dot and cross formula. So ethene, propene, butane, pentane, hexene, heptane, all the series will be given like this. You can write the formula by putting the value of number of carbon atoms in the general formula and get the rest of the formulas accordingly. Okay, before we will move ahead, I am going to write a formula. You will tell me what is the name of this formula, or you can tell me how many number of carbon atoms are there. 1, 2 and 3. Can you please name and write it in comment box before you will move ahead. First of all, tell me with 3 number of carbon atoms, what will be the name? Start. Or write it in comments. Yes, it is prop. And then rest of all the hydrogen atom. And if there is carbon-carbon single bond, the name end will ane, propane. But if we have carbon-carbon double bond in the series and we have 3 carbon atoms, number of carbon atoms are 3, again the name will be like this, prop, and because of the presence of double bond we will write it ene. The rest of all the bonds will be utilized by the hydrogen atoms like this. We will utilize it like 1, 2, 3, 1, 2, 3 and 1 is 4 here. 1, 2, 3, 4. So you will complete all the chains like this. So this is the difference between alkane and alkene. So you can write the formulas accordingly by utilizing all the 4 bonds of the carbon atoms. Now another homologous series in your syllabus is the alcohols. The functional group of alcohol is OH, and the name, when we will name this, it will end up in ol. The functional group of alcohol is OH. The hydrocarbons which contains OH in the series, then we will say that this is the compound of alcohol. So alcohols have OH in its compound and the name end is up ol, methanol. If it is having 2, ethanol, propanol. So all, if it will end up with all, it having a family of alcohols. So general formula for the alcohol is CnH2n plus 1 or OH. This is the formula, general formula of alcohol, in which we will put the value and get the molecular formula accordingly. Right? For example, I have written the formula of ethanol. How we will put the value here? If we have CnH2n plus 1 OH, and we are going to write the formula with the 3, for example, we have to write the formula number with 3 carbon atoms. How we will write it like this? 2 into 3 plus 1 OH. So C3 H2 3 is into 6. So we will write it like this. C3 H2 3s are 6 plus 7 OH. So this is the way through which we can write the molecular formula of this alcohol. So in somehow we can write the molecular formula like this. C3, we will condense it like this, H8 and O. So this is another way to write the molecular formula. So molecular formula is ethanol with 2 carbon atoms. With ethanol is C2H5OH. With ethanol it is CH3, CH2 and OH. This is the full displayed structural formula. So if we are going to have a full displayed structure formula, we have to show all the bonds present between the number of elements. So CH3, all the open bonds will be shown in the full displayed structural formula. Structure formula and full displayed structure formula is going to show all the bonds present in the molecule. How we will condense it? Like good CH3, but this is a common way you will find to write it like this, but this is not the good way to write. You have to write CH3, CH2 and OH. The better way to write it like this, the condensed formula. But most of the time you can find it like this, and in some books you can find this is the correct one. But better way to write it like this, CH3, CH2 and OH. Because bond is between carbon-carbon, single bond. So this is the formula of ethanol. This is a condensed formula of ethanol. And if we are going to discuss about the dot and cross, yes. How many? I am going to ask the question. Please comment in comment box. How many electrons we will write in single bond? How many electrons we will write in single bond? Yes, we will write 2 electrons. One from carbon, another from hydrogen, oxygen. One is from carbon, other from carbon. Respective bond with the hydrogen. If bond is between the hydrogen, then we will use the electron of hydrogen. So this is the way through which we will write dot and cross formula of alcohols. So this is the way through which we will write the dot and cross formula of alcohols. Now, another and last homologous series, which is basically in your syllabus, and we have to consider it very vigilantly, because a little difference in applying the general formula in it. How? Carboxylic acids are the organic acids. Carboxylic acids are the organic acids, and organic acids are the weak acids. So carboxylic acids are the organic acids. It has a functional group like C double bond OOH. It can be written like this, or it can be written like this, C double bond O and OH. Here are the ways through which we will write the functional group. Whenever we will have this group any way, written in any way, if we will have this group in a chain of hydrocarbon, then we will say that this is the formula of carboxylic acids, because this is a functional group. Functional group is one which gives its properties to the compound, that this is the functional group. So it will have the properties of weak acids. Organic acids are weak acids. The now major part is this, the general formula. If we will consider the general formula of carboxylic acids, then we must know that this is having CN, H2N plus 1 COOH. How to apply this formula? First of all, I would like to teach you one method through which you people can write. Most of the students have done this mistake a lot. So I would like to prefer you people don't use this formula, but I will teach you how to use this formula in the compound. I will give you that suggestion as well. But whenever you have to write the formula of organic acids, first write down its structure formula. In methanoic acid, meth means 1. Only 1 carbon atom will present in methanoic acid. The name will be end like oic acid. Oic acid. So ending name will be for the carboxylic acid is oic acid. Whenever we have methanoic acid, you must familiar, this is the group of functional group of carboxylic acid. So if we are going to write the functional group here, meth means 1. In chain we are going to have 1 carbon atom. So if we will write 1 carbon atom, the 1 carbon atom, how many bonds are utilized? 1, 2, 3, and in the rest we will add this H. So this is the methanoic acid. If we want to write the ethanoic acid, one will be the functional group. Eth have 2 carbon atoms. So in chain we will have 2 carbon atoms. Complete all the 4 bonds of carbon 1, 2, 3, 4. And if we are not having any other one, we will use this carbon atom. So this is the way to write the ethanoic acid. And if we are going to write the formula of propanoic acid, how will we write? First of all, we will write the functional group. A functional group can be written in either side. It can be written in left side or on the right side. It will be up to you. Propanoic acid, 3 carbon atoms in the chain. The rest of all bonds will be associated with the hydrogen bonds. So 1, 2, 3, 3 carbon atoms propanoic acid. All carbon atoms must utilize 4 bonds. 1, 2, 3, 4. Again check it. 1, 2, 3, 4. Don't forget to check it. In the beginning, you must practice with utilizing all the 4 bonds of propanoic acid. And if we are going to discuss the butanoic acid, yes, pause the video for a while and all of you draw the structure of butanoic acid. If you people are successful to write this formula of butanoic acid, then comment and say, yes, I am successful. Now, butanoic acid, one is functional group. Total 4 carbon atoms should be there in the chain. 1, 2, 3, 4. The rest of all bonds will be utilized by the hydrogen bonds. All carbon atoms must form 4 covalent bonds. Otherwise, your formula will be wrong. So, first of all, I would like to suggest you people use this method to write down the formula of carboxylic acid. Now, I am going to teach you how to write the formula of methanoic acid, ethanoic, propanoic, butanoic acids in all the chain by using this general formula. How we will use it? This is the way through which we will use it. I will teach it to you now. Yes. Okay. So, this is the formula. Cn, H2n plus 1 and OH. COOH. Sorry, COOH. This is the way through which we are going to use this formula. Now, the question is, what is the way? Already we have 1 carbon atom in this. So, for 1 carbon atom, if the number of carbon atom is 1, I am going to write N is the number of carbon atom. For number of carbon atom N, we will write here the value of N is 0 in the formula and put the formula as here. If number of carbon atom is 1, we will take N is as 0 and we will write the formula like this. Cn in place of N we will write 0. H2 N multiply by 0, we have 0 value plus 1 and again the functional group C double bond OH. How we will write this? C0 means it got cancelled. H200 plus 1 only 1 C double OH. So this is the way through which we will write. We don't mention 1 here like this. We will condense this formula like this. HC, molecular formula of this one is this. This is the molecular formula or condensed formula. How we will write HCOO and H. This is the methanoic acid. So if we are going to write number of carbon atom 2, we will take it number of carbon atom 1 here in the formula. And for this we will add 1 H2N H1N into 1 COOH. 2 multiplied by 1. Here we have 2 multiplied by 1 plus 1. So if value is C1, 2 ones are 2 and plus 1 is 3. This is the formula of acetic acid or citric acid. The common name of acetic acid, ethanoic acid, is the acetic acid. So this is the way. If we will condense this, look at here, CH3 COOH. And practice a rest of the compounds like this. To write the molecular formula like this, we can write the molecular formula is like this. CH3, CH2. It can be written in both ways. Better to write like this. C double bond O or OH, or you can condense it. It will be up to you how to write it. But this is the way through which we will write the formulas of carboxylic acids. And the next one. Okay, branched and unbranched chains. Unbranched chains means there is no branch. It is a straight chain. Like we are going to write, for example, we have to write the formula of butane. If we write the formula of butane, then we will check 1, 2, 3, 4. It is a family of ane, alkane. All are single saturated hydrocarbons. Yes. Rest of all will be attached with the hydrogen, because it is only the hydrocarbons which contain hydrogen and carbon only. None of other element is present here. Rest of all will be utilized for bonds. So this is the formula of butane. And if this is a straight chain, then we will say this is the unbranched chain. Unbranched chain. If it is a straight chain, then we will say this is the unbranched chain. So for unbranched chain, we will write a straight chain and we will name it like N-butane. N-butane means it is a straight chain and we will name it like N-butane. If we have pentane, again we will write a straight chain of pentane. If there is a change in the position like 1, 2, 3, if we are going to get a carbon atom like this, CH3 is here, okay, if we will write it like this is the way where we are going to get another carbon atom in the chain. So this one is the branch chain when we are going to have a carbon atom in another position. It can be position can be changed like this. It can be like this. One carbon atom is here, another is here, one is here. So this is another chain. The rest of the bonds will be utilized. All carbon atoms must utilize 4 carbon atoms, 4 bonds. All carbon atoms must utilize 4 bonds, 4 single bonds in alkanes. So here we are going to discuss the branch chain and unbranched chain. For the branch chain, naming is little different. How we will name the branch chain? It is going to have this way. First of all, remember, when from any alkane we will remove one hydrogen, then this methane will convert into a name that is methyl. It will form CH3, methyl. If in the chain alkane is not in the series of this carbon atom, it is beyond this, then we will name it like methane. And if we are going to have ethane and one hydrogen atom is removed from this, it will become methane to methyl. Methane will convert into alkyl group. This is the alkyl group. Name will end up with "-ile". Methane will convert into methyl. Here is ethane, and ethane will form ethyl. So we will name this like methyl. Like now how to name this? First of all, we will check and start to name this branched near. If we have, we will check if the near this methyl is near the carbon atom, then we'll start the counting of it. So here same in second position, here in the second position methyl group is there. So we will start counting from either side. 1, 2, 3, 4, 5, and 6. We have six number hex. We have 6 single covalent single bond, so family is N. We have hexane in this straight chain. Okay. Another thing we will check. Methyl group CH3 is in the position of 2, in the position of 4, in the position of 5. We will write 2, 4 and 5. How many methyl are there? One will be mono, di, tri. So here are three. For 3 methyl groups we will write tri. 2, 4, 5 tri methyl hexane. How will we name this? We will check the position of this. If it is near this carbon, this chain, we will start counting. It is between, so we can start from either side, from here or there. It is equal. 1, 2, 3, 4 and 5. In the straight chain, yes, 5 carbon atoms, pentane. And count, if we will check the position of methyl, 3 methyl pentane. Okay, I am going to write another question. Name it and write the name in the comment. Then check the answer here in this video. You will pause the video, then you will name it, then you will check the name, which I will write it down. Okay, I am going to write 1, 2, 3, 4. Right? 1 is here, CH3. Another one is here. The rest of all will be utilized for covalent bonds with the hydrogen atoms. Now, pause the video and name this compound. We will start counting from that carbon where methyl group is nearby. So pause the video and start counting. Start naming it. Okay. Now we will name it now. 1, 2, 3, 4. Straight chain. Butane. With 4 carbon atoms. 4 carbon atoms, but N is the homologous series of alkane. Right. How to count? We will check. Yes. 2 position. And in 3 position. How many 2 methyl means dimethyl butane. So this is the way through which we will name the branched chain and unbranched chain. Unbranched chains are the straighter chains, whereas the unbranched chains are the straighter chains, where are the branched chains having methyl or ethyl groups in this chain. But in your syllabus only methyl group will be introduced here. So this is the end of the lesson. I hope so that you people have learned it very well. If you want to ask any question and any query, and if you want to learn any topic, you can comment in comment box. I will teach you and prepare a lecture for you people. I hope so that you people have learned well. Stay safe, stay at home. Signing off, Miss Aisha Manzoor.